Hello everyone, my name is prashanth.kumar. I'm an assistant professor in the Department of Computer Science and Engineering, Canara Engineering College. Today we are going to study the Module 3 of Cloud Computing and its application. The subject code is 17CS742. Coming to the Module 3, there are two chapters. The first one is Concurrent Computing. The second one is the High Throughput Computing. So in this video, we are going to learn about thread programming, introducing parallelism for single-machine computation, programming application with threads, what is a thread, thread APIs, techniques for parallel computation with threads. Thread programming, throughput computing. So it focuses on delivering high volumes of computation in the form of transactions. So transaction is very important here. Initially related to the field of transaction processing, throughput computation has since been extended beyond that domain. Multicore systems. Advances in hardware technologies led to the creation of multi-core systems, which have made possible the delivery of high throughput computation even in a single computer system. Now we can see single computer system, but there will be multi-cores. So multiple number of cores are there. So in the diagram also you can see core 1, core 2, core 3, core and core 4. There are 4 cores are present in this particular system. In this case, throughput computation is realized by means of multiprocessing and multithreading. So as you can see, there are 4 cores are there. Every core will be having a cache and it will be having a shared memory. And the bus interface you can see in the diagram of chip components. Multiprocessing is the execution of multiple programs in a single machine. So in the name itself, it says that multiprocessing. So it will be having multiple processes. So you can see process 1, process 2, process 3. There is a main process which is subdivided into process 1, process 2, process 3. Multiple processors are there in a single machine. Coming to multithreading, related to the possibility of multiple instruction streams within the same program. So you have a main process, and inside the process, you already know that about the thread. It is nothing but the building block of every process. So there is a main process and there are multiple threads. You can see thread 1, thread 2, thread 3. So it is called as multithreading. Introducing parallelism for single machine computation. Parallelism has been a technique for improving the performance of a computer. Of course, it will increase the performance of a computer because parallelly multiple programs will be running. Since the early 1960s, when Burroughs Corporation designed the D825, the first MIMD multiprocessor ever produced. So you can see the logo I have put over there. So that is the company logo and the people working on parallelism. So that is the first MIMD multiprocessor ever produced by the company. From there on, a variety of parallel strategies have been developed. You can see parallelly how exactly the program will be running. So you have a processor, every processor has a cache, and there is a main memory shared between them and the input-output system. So parallelly processor 1, processor 2, processor 3, and the 4 will be working so that it will improve the processor speed and the performance. Multiprocessing, which is the use of multiple processing units within a single machine. You can see there is a single machine, and in that multiple processes are there. You can see process 1 runs on CPU plus memory. You can see process 2 running on the CPU plus memory, process 3 running on the CPU plus memory. So it will be having a main process. Has gained a good deal of interest and gave birth to several parallel architecture. So multiple processes is called as a multiprocessing unit. Symmetric multiprocessing. And one more thing is called as the asymmetric multiprocessing. So let's see what is symmetric multiprocessing. Features the use of similar or identical processing units. So all these processing, there will be multiple processing will be there, but all are similar to share the computation load. You can see in the diagram, user, and it will be having multiple processing units and the operating system. So now coming to asymmetric multiprocessing. Involve the concurrent use of different processing units that are specialized to perform different functions. Here, similar function, but here it is the different function. It is called as asymmetric multiprocessing. So you can see multiple processes are there in the right side, this diagram. and you can see multiple process. Every process will be having its own function. So it is different, but here it will be having a similar function. So in this diagram also you can see. So symmetric multiprocessing and the asymmetric multiprocessing, you can see in symmetric multiprocessing, multiple processes are there. CPU 1, CPU 2, CPU 3 is there, and multiple processes also you can see P1, P2, P3, and it will be having a shared memory. Whereas asymmetric multiprocessing will be having no shared memory because it will be having different functions over here. Now coming to non-uniform memory access, NUMA, NUMA, defines a specified architecture for accessing a shared memory between the processors. You can see multiple processors, but there is no shared memory in the uniform memory access. There is only one memory. But here, coming to non-uniform memory access, defines a specific architecture for accessing a shared memory between the processors. How exactly the sharing of the memory is done? You can see CPU, CPU, CPU. There are 4 CPUs and the memory. So it is the non-uniform memory access. And the left side is the uniform memory access. Clustered multiprocessing. The use of multiple computers joining together as a single virtual computer. You can see on the right side, these are all the multiple computers, small boxes, what you find, those are the multiple computers together joined to form a single virtual computer. So multiprocessing unit. So that's what it is shown over there in the left side. This is the entire computer system where it will be having, it is called, one single system is called as one cluster. So every cluster will be having multiple cores, and level 1 memory is there, level 2 shared memory is there, data bus is there. Okay, so the use of multiple computers joined together as a single virtual computer is called as clustered multiprocessing, and it will be having a physical memory, common physical memory. Symmetric and asymmetric multiprocessing. You already seen this particular topic are the techniques used to increase the performance. Why exactly asymmetric or the symmetric? You got to know that symmetric multiprocessing, it will be having a shared memory. Asymmetric multiprocessing will not be having a shared memory. Here a single purpose multiprocessors are there. Here dual purpose, multiple purpose multiprocessing are there. So why exactly it will be used? The main agenda is to increase the performance of commodity computer hardware. Multicore technology. So you might have heard about dual core, multi-core, quad core. So it is about the multiple cores in the single system. It is the latest evolution of asymmetric multiprocessing. So this is the example for symmetric multiprocessing. You can see core A, core A, core A, 4 times it is written. So it is a common functionality with their multi-core technology. It is a quad core memory. Now coming to graphical processing units, GPUs is an application of asymmetric processing. CPU for symmetric, GPU for the asymmetric. So in the CPU you can see multiple cores are there, but in the GPU you have thousands of lakhs of a huge number of cores. So that's what is written over there. Here it is a multiple core, here it is a hundreds of cores. Now graphical processing unit, the same thing. You can see the architecture over here, how exactly it will be shown. Which are de facto processors, is an application of asymmetric processing, which you already learned. See, you can see on the left side CPU and on the right side GPU. So CPU, it will be a quad core, you can see, sorry, it is a 4 cores are there, core 1, core 2, core 3, core 4. And coming to GPU, it will be having thousands of cores. Now, multi-core technology. It is a latest evolution of symmetric multiprocessing. Multi-core technologies are now of important because of the physical constraint imposed on frequency scaling. Earlier, they used to use the concept of frequency scaling. Now, after multi-core technology has come, frequency scaling, nobody is using. So it will become no longer possible to increase the frequency of the processor clock without paying in terms of power consumption and cooling. It is very difficult to have continuously increasing gap between the processor and memory speed. Increasing the instruction level parallelism in order to keep a single high performance core busy. It is also very difficult. So this ends the frequency scaling era and the beginning of multi-core system. So that's what I was talking about here is, earlier you used to have a concept called the frequency scaling, where all this functionality will not be done. but using the multi-core technology, all this particular part can be done with the high throughput. Multi-core systems, which we have already seen, where these are composed of a single processor that features multiple processing cores that shares the memory. Each core has generally its own L1 cache. You can see level 1 cache for every core. Core 1 L1, core 2 L2, and core N you have L1. And the L2 cache is common to all the cores, which connects to it by means of shared bus. You can see a shared bus which connects all these things, but there is a single shared memory called as the level 2 cache. Dual and quad core configuration. I need not tell about dual core. 2 cores are there, quad core, 4 cores are there. Are quite popular nowadays. Everyone will be having the laptop. You might have found a dual core or a quad core processor in it. Constitute the standard hardware configuration for commodity computers. Architectures with multiple cores are also available but are not designed for the commodity market. Okay, now the comparison, dual core and the quad core. You can see here number of cores of data lines. Dual core you have 2 processing cores, quad core you have 4 processing cores. Speed, which is speed. Dual core is less powerful in terms of speed, but quad core is faster. Task. Dual core does not support multitasking like quad core. Quad core is designed for multitasking. Heat. Dual core is lighter and no heat is generated when working, of course, because there are only 2 cores are there. But coming to quad core, 4 cores are there. Quad core processing generates heat, which can heat up the device, because again, it will be having a multitasking, multi-programming will be done. Energy consumption. Dual core consumes less power, quad core consumes more power. Video. Dual core lacks in graphics. Graphics is less, but quad core is better equipped to handle high quality graphics. Let's see what is operating system. So it defines the runtime structure of applications by means of the abstraction of process and thread. You can see multiple applications running in the operating system. You can see the application monitor, printer, mouse, keyboard, hard drive, everything will be running. Okay, and in the same concept of process and thread, you can see an operating system will be having multiple processors, and every process will be having multiple threads running in it. Process. It is a runtime image of an application, a program that is running, which is under process. Correct? Now, if you can see the diagram over here, every process will be having multiple threads working at the same time. Now, coming to the thread, identifies a single flow of the execution within the process. So, inside a process, single flow of execution will be done by a single thread, one more thread, and one more thread. There are 4 threads running under the process. Multiprocessing is just one technique that can be used to achieve parallelism. And it does that by leveraging parallel hardware architecture. You can see the diagram, multiprocessing, main process divided into multiple processes over there. Every process will be given to in the same system, the different CPU plus memory. You can see in the diagram. Now coming to multithreading, multiple threads running in the single process. You can see thread 1, thread 2, thread 3, multiple threads running under a main process. When it provides a structure for explicitly defines multiple threads within the process, which is called as the multithreading. Multitasking. So multitasking is nothing but you might have seen a person's. You can see a person's diagram over there where he is doing multiple tasks at the same time. So he's drinking tea and he's on call and he's doing multiple tasks at the same time. A system that allows the execution of multiple processes at the same time is called as multitasking. So you can see task 1 browser, task 2 Excel, task 3 Paint, task 4 media player at the same time happening in the operating system. So multiple processes at the same time happening is called as multitasking. So this ends the first part of Unit 3. Thank you so much.